Hello everyone, this is Sedi and welcome to Sedi's Mathverse. For today's video, we will discuss geometric sequence, one of the topics that are in grade 10. Without further ado, let's get started. First, let us define a geometric sequence. A geometric sequence is a sequence where every next term is obtained by multiplying a constant number. That constant number that is being multiplied is called the common ratio. The usual symbol for common ratio is R. So what is the formula of a geometric sequence? Given its first term, we have a sub n, the nth term of the sequence, is equal to a sub 1, which is the first term, multiplied by r raised to quantity n minus 1. Our r here is the common ratio. So, we have here nth term, a sub 1 is first term, and r is our common ratio. However, this formula changes once there are no first term given. Given a sub m, which is the mth term of the sequence, and a sub n being the nth term of the sequence, we have this formula. A sub n is equal to a sub m multiplied by r raised to the quantity n minus m. Now, we will prove that this formula is indeed the case if a sub 1 is not given. So, we have a sub n is equal to a sub 1 multiplied by r raised to quantity n minus 1 if the first term is given. We will introduce the mth term, which is equal to a sub 1 multiplied by quantity r raised to quantity m minus 1. And then, we will divide these two equations. So, we will divide a sub n by a sub m. Then, we will divide their equivalent values. So, we have a sub 1 times r raised to quantity n minus 1 for the numerator. And then, for the denominator, a sub 1 times r raised to m minus 1. This cancels out the two a sub 1s. So, all that remains is r raised to quantity n minus 1 over r raised to quantity m minus 1. Then, we use the laws of exponents to simplify this problem. This becomes r raised to quantity n minus 1 minus the exponent in the denominator, which is by division rule, we have quantity m minus 1. Then, this becomes r raised to quantity n minus 1 minus m plus 1, in which these negative 1 and positive 1 will be cancelled, leaving us r raised to n minus m. Finally, multiplying both sides by a sub m gives us a sub n equals a sub m multiplied by r raised to quantity n minus m, which is indeed the equation we wanted. And that is the proof for the formula without the first term. So we will try some example problems related to geometric sequence. So here's our first problem. We are given a sub 1 equals 4, a sub 4 equals 108. We will find the common ratio and the fifth term. We will use the formula a sub n equals a sub 1 multiplied by r raised to quantity n minus 1, since a sub 1 is involved. A sub 4 is equal to a sub 1 r raised to quantity 4 minus 1. So this is also r cubed. Now, we substitute the values of a sub 4 and a sub 1. 108 equals 4r cubed. Divide both sides by 4. 27 equals r cubed. Then, we get the cube root of both sides. So we get r equals 3. And now, we have the common ratio. So this is okay now. All we have to find is a sub 5. R equals 3. Let's bear this in mind. And we will find a sub 5 using two methods. First, using a sub 1, and second, using a sub 4. So, a sub n equals a sub 1 multiplied by r raised to n minus 1. So, a sub 5 equals a sub 1 r raised to quantity 5 minus 1. So, this is r raised to the fourth power. Then, a sub 1 equals 4 times the common ratio, 3 raised to the fourth power. This becomes 4 times 81, which is 324. The other approach uses the generalized formula. So a sub n equals a sub m multiplied by r raised to n minus m. Then a sub 5 equals a sub 4 multiplied by r raised to quantity 5 minus 4, which is just r raised to the first power, or r. Then we have 108 times 3, which is equal to 324. I believe it is easier to find the succeeding terms if you will use the closer term. Since as we can see, we have to raise 4 in order to find a sub 5 in this case. But here, all we have to do is to multiply two numbers. Or we might raise exponents here, but it's relatively smaller. Anyways, moving on to the next problem. Now, as we can see, this next problem doesn't have a sub 1. So I will present two ways to solve this problem. First is the old school method, wherein we need to find a sub 1 and r first to find the other terms, and the second one, which uses the generalized formula. So first, let's begin with the old school method. A sub 2 is equal to a sub 1 multiplied by r, 2 minus 1. So that's just 1. So we let r as it is. So a sub 5 is equal to a sub 1 multiplied by r raised to 5 minus 1, which is 4. So this is our a sub 5. Now, to solve for r, we need to get rid of a sub 1. So a sub 1 multiplied by r raised to the fourth power all over a sub 1 r. This gives us r cubed. This is ugly. Also, we know that a sub 5 is 112 and a sub 2 is negative 14. So r cubed is equal to negative 8. And r is obtained by getting the cube root of both sides. So r equals negative 2. And that is how we get the common ratio. Then, we need to find a sub 1 as well. Negative 14 is equal to a sub 1 times negative 2. And dividing both sides by negative 2 gives us 7 equals a sub 1. So, this is the old school method of finding the common ratio, wherein there is no generalized formula, at least in the textbooks. Then we will solve for a sub 3. So it is required for us to use the a sub n equals a sub 1 thing. So a sub 3 is equal to a sub 1 multiplied by r raised to 3 minus 1. We know that a sub 1 is 7 and r is negative 2. So we have 7 multiplied by negative 2 raised to 2, which is 7 times 4 equals 28. But how about using the generalized formula? A sub n is equal to a sub m multiplied by r raised to quantity n minus m. 112 or a sub 5 is equal to a sub 2 r. 5 minus 2 is 3, so r cubed. 112 equals negative 14 r cubed. Dividing both sides by 14 gives us 8 equals negative r cubed, or negative 8 equals r cubed. Getting the cube root of both sides will yield the same value, or negative 2. And then, to get a sub 3, we will just plug in a sub 2 and use this same generalized formula. A sub 3 is equal to a sub 2 multiplied by r raised to quantity 3 minus 2, which is just r raised to the first power. So, a sub 3 equals negative 14 times negative 2, which is 20. As we can see, we got the same results, but the first method took us a longer time to write the solution out because it needs to find some more extra terms. The generalized formula is more efficient if you want to use it on competitive or shortcut purposes, but if your teacher requires you to do a full solution, use the first method. For the rest of the example problems, I will use the generalized formula. So, let's proceed with the third example problem. In a geometric sequence, the first 5 terms are x, 36, y, z, and 288 respectively. What are the values of x, y, and z? So we have a sub 5 equals 288, then a sub 2 equals 36. We are tasked to find a sub 1, a sub 3, and a sub 4. First, we will find the common ratio. So we have a sub n equals a sub m multiplied by r raised to quantity n minus m. Then a sub 5 equals a sub 2 r raised to quantity 5 minus 2, which is 3. Then 288 equals 36r cubed, and dividing both sides by 36 gives us r cubed equals 8. Getting the cube root of both sides gives us r equals 2, and here is your common ratio. How can we find a sub 1? A sub 1 can be found by using a sub 2 is equal to a sub 1 r raised to 2 minus 1 is equal to a sub 2 equals 36, then a sub 1, then r is equal to 2, so a sub 1 equals 2. A sub 1 equals 36 over 2, which is 18. Then a sub 3 is equal to a sub 2 multiplied by r. Then a sub 3 equals 36 times 2, which is 72. Lastly, a sub 4 is equal to a sub 2 multiplied by r raised to 4 minus 2, so 4r squared, which is equal to 36 times 2 squared equals 144. That is it for today's video, ka-Mathverse. I hope you learned something and enjoyed this video. If you did, subscribe to our official YouTube channel and follow our social media accounts whose links are shown here. That is it, guys. And remember that mathematics is incomplete without you, and chase your greatest moonbeams. Till next time.